Hello again, Psych 370 students, and welcome to another video lecture for week 12. In my last one of these, I talked about extinction and operant conditioning. So in this one, which is actually part of a recorded Zoom class, I'm going to be talking mostly about the partial reinforcement extinction effect. However, before I do that, I really need to review the concept of resistance to extinction first, so that's where this lecture is going to begin. So guys, when we talk about resistance to extinction, remember, we're talking about the extent to which that behavior persists when it's no longer being reinforced. How well does that behavior resist this attempt to extinguish it? How long does it stick around even though it's not being reinforced? That's what resistance to extinction is all about. So if a behavior seems like it's very resilient, if it seems like it's very persistent, if it keeps getting performed for a long time, even when it's not getting reinforced anymore, then you'd say that behavior is highly resistant to extinction, right? It resists extinction well. So that's what you're seeing in this graph, which again is showing responses per minute over time. This is not a cumulative record because we're looking at response rate here, not total responses. So this behavior is highly resistant to extinction. When you first introduce extinction, right here on this dashed line, there's that initial burst, right? The response rate goes up for a little while, and then it slowly dissipates. The animal gradually stops performing the response. Compare that to this one, where there's a much more abrupt decrease in response rate once the extinction begins. And so we would say that this response, whatever it is not very resistant to extinction. And this one, represented by this graph, is highly resistant to extinction. Okay, so this response is being extinguished quickly. The animal gives up on this response quickly, so it's not resistant to extinction. The animal sticks with this response for much longer, so it's resisting extinction much better, right? Now, resistance to extinction is influenced by several factors. Okay, your book talks about a few of them, but probably the most important one is the schedule of reinforcement that was in effect before the extinction phase began. So guys, one of the most reliable findings in all of psychology really is that partially reinforced behaviors tend to stick around for longer, right? They tend to persist for longer. They tend to be more resistant to extinction than continuously reinforced behaviors. People and animals will make more responses during extinction after partial reinforcement than they will after continuous reinforcement. And so as I mentioned last week, that phenomenon has a name. We call it the partial reinforcement extinction effect. Okay, so partial reinforcement, intermittent reinforcement, where you're not reinforcing the behavior every time, but only sometimes when it occurs, that tends to result in behaviors that are more resistant to extinction than continuous reinforcement does. And this is pretty intuitive when you think about it. I mean, after all, if a slot machine breaks and a vending machine breaks, so if they both go out of order, if we introduce extinction on both of these machines so that the slot machine won't pay out and the vending machine won't dispense items, then, I mean, which one do you think people are going to keep putting their money into for longer? The slot machine, right? Because playing the slot machine got reinforced on a partial schedule, right? You would win sometimes on the slot machine, not every time. And using the vending machine gets reinforced on a continuous schedule, right? So when the vending machine eats your money, when it doesn't give you the reinforcer, when you enter the extinction phase with the vending machine, you're not going to keep putting money into the vending machine over and over again like an idiot, right? You'll give up on that behavior quickly, right? But you'll keep putting money into the slot machine for longer because of the partial schedule that playing the slot machine had been on before extinction. Okay. So again, partially reinforced behaviors tend to be more resistant to extinction than continuously reinforced behaviors do. That's the essence of the partial reinforcement extinction effect. And so what I want to do for the rest of the day here is just summarize a few of the explanations that psychologists have come up with for why this is a thing. Why do we have this partial reinforcement extinction effect? There are basically 4 ideas that I need to talk about here. Okay. And first of all, one idea on this is what's known as the discrimination hypothesis, which basically suggests that the beginning of the extinction phase is just easier to notice after continuous reinforcement than it is after partial reinforcement. Continuous reinforcement, in other words, makes it easier for the animal to discriminate between acquisition and extinction. Okay, so it's easy to tell that the extinction phase has begun if you're going from every response getting reinforced, like in continuous reinforcement, to no response getting reinforced. Right? So that's the idea here. But it's harder to tell that the extinction phase has begun. It's harder to discriminate acquisition from extinction if you're only going from partial reinforcement to extinction. Because when a partially reinforced behavior stops getting reinforced, then you're not going from getting the reinforcer every time to not getting it at all, right? You're not going from always to never. You're not going from all of your responses getting reinforced to none of them getting reinforced like you would with a continuously reinforced behavior. Instead, you're going from some to none, right? You're not going from all to none. You're going from some to none. And again, that's not as noticeable, right? So basically, since partial reinforcement isn't as different from extinction as continuous reinforcement is from extinction, partial reinforcement makes it longer for you to realize, makes it take longer for you to realize that you're in extinction now. Partial reinforcement makes it take you longer to realize that that reinforcer really isn't coming now. And so that's why you're going to take longer to give up on the behavior. So for example, consider the slot machine versus vending machine example that I just talked about. When the vending machine breaks, when it eats your money and doesn't give you the soda or the candy bar or whatever, then you know right away that something's wrong, right? Because in the past, you had always gotten this reinforcer for performing this behavior, right? That behavior had gotten continuously reinforced before. So now when it doesn't get reinforced, you're going to immediately suspect that you've entered an extinction phase. You're going to immediately know that something has changed about the contingency between performing this behavior and getting this consequence, right? You can detect very quickly that extinction has begun if you're entering extinction from continuous reinforcement, right? But when the slot machine breaks, when the slot machine doesn't pay out, that's harder to notice, right? It's harder to tell that playing the slot machine is now on an extinction schedule, because even when that slot machine was working properly, you still would have had experiences where you played and didn't win, right? You've made these unreinforced responses before with the slot machine. So the partial schedule that you were on then, again, it's not as different from the extinction schedule that you're on now. So it's harder to tell. It's harder to discriminate, harder to tell the difference between those two schedules, right, of partial reinforcement and extinction. So according to the discrimination hypothesis, that's why you keep putting your money into the slot machine for longer than you put it into the vending machine. Okay. So that makes sense. I mean, it's an intuitive idea, the discrimination hypothesis, but unfortunately, not all of the research supports it. There's some evidence that contradicts this idea. So for example, in an experiment by a guy named Herbert Jenkins, what he did was he trained some pigeons with partial reinforcement first. He trained other pigeons with continuous reinforcement first, and then he gave all of the pigeons an extended continuous reinforcement session before extinction began. Yeah. So one group of pigeons only ever experiences continuous reinforcement. The other one experiences partial reinforcement first and then continuous reinforcement. And then he puts all of the pigeons on an extinction schedule. Okay. So guys, the important thing there is that extinction was introduced immediately following continuous reinforcement for both groups. So they both experienced the same abrupt transition from continuous reinforcement to extinction. In other words, the switch to extinction should have been equally noticeable for both groups of pigeons. However, as you can see in the graph here, the ones that initially experienced partial reinforcement went on to show much greater resistance to extinction. Okay, so this graph is showing the average number of responses that were made by both pigeons, both groups of pigeons, over the course of 10 extinction sessions. And as you can see, the ones who were originally on the partial schedule made about twice as many responses during extinction as the ones who only experienced continuous reinforcement. Okay. Now, other studies like this have been done too with similar results. And so what those findings suggest is that the greater persistence, the greater resistance to extinction that we see after partial reinforcement, it doesn't seem like that's due to a greater difficulty in detecting the start of extinction. Okay, doesn't seem like animals just have a harder time telling the difference, discriminating between partial reinforcement and extinction. They seem to learn something more long-lasting from partial reinforcement. Basically, they seem to learn not to give up. Right? Partial reinforcement seems to teach them not to give up in the face of failure, not to give up in the face of non-reinforcement. And they continue that into the extinction phase. So that's why they persist for longer during extinction. So the discrimination hypothesis, like I said, on the surface of it, it seems to make a lot of sense, but the evidence doesn't really support it. At least this evidence like this doesn't support it. So I need to talk about some other explanations of the partial reinforcement effect. This next one is called the frustration hypothesis because it suggests that during partial reinforcement, not getting the reinforcer after some of its responses causes the animal to feel frustrated, right? It experiences this emotional state that we call frustration, but it continues to respond while it's in that frustrated state. And since it's on a partial reinforcement schedule, it eventually gets the reinforcer. Okay? One of those responses eventually produces the reinforcer. And as a result, the animal comes to associate its own feelings of frustration with eventual reinforcement. So in other words, that frustrated emotional state becomes a discriminative stimulus for the animal. It sort of signals to the animal that the reinforcer is available to it if it continues to respond. And so the animal learns that it will eventually get the reinforcer if it keeps making the response in the presence of its own frustration. Okay. So it learns that, okay, when I feel frustrated like this, when I've felt frustrated like this before, I've kept at it and it's eventually paid off. And so it associates responding in that frustrated state with eventually getting the reinforcer. And according to the frustration hypothesis, that association between frustrated responding and eventual reinforcement, it carries over into extinction, okay? And so obviously during extinction, the animal performs the response again. It doesn't get the reinforcer again, and that makes it feel frustrated again, right? But again, since the animal has basically learned that frustration is a cue to keep responding, that's what it does, it persists, right? However, animals who have only been continuously reinforced in the past haven't experienced frustration, right? They experience frustration for the first time during extinction, right? Because they've never failed to get the reinforcer before, right? And so since they haven't learned to keep responding when they feel frustrated, like partially reinforced animals have, they give up faster, right? Continuously reinforced animals don't associate frustrated responding with reinforcement. They've never made a frustrated response and gotten reinforced for it before, and they're not gonna now either during extinction, so they're gonna give up faster. So that's the idea behind the frustration hypothesis. It says you learn to associate being frustrated and responding with getting the reinforcer, right? So responding in the presence of your own frustration is something that paradoxically you've learned to do, according to this view. So that's the explanation that the frustration hypothesis gives for the partial reinforcement extinction effect. And guys, a similar kind of idea is what's known as the sequential hypothesis, which was originally proposed by this guy, John Capaldi. Okay. So according to Capaldi, during partial reinforcement, when the response is not followed by the reinforcer, the animal acquires a memory of that non-reinforced response. And Capaldi says that it's that memory and not the animal's frustrated emotional state that acts as the discriminative stimulus, okay? So in other words, an animal on a partial reinforcement schedule learns to associate its memories of non-reinforced responses with the eventual delivery of the reinforcer. So similar kind of idea here, right? Except that Capaldi is talking about the animal's memories, whereas in the frustration hypothesis, this Abram Amsel guy was talking about the animal's frustrated emotional state. Okay? So we're just basically swapping out an emotional state for a memory, and then we get the sequential hypothesis. Okay. So frustration hypothesis says animal learns to respond in the presence of its own frustration. Sequential hypothesis says no, the animal learns to respond in the presence of its own memories of non-reward, its own memories of making the response and then not getting the reinforcer. Okay. So basically partial reinforcement teaches the animal to make the response whenever it remembers not getting reinforced for making the response. Yeah. But an animal on a continuous reinforcement schedule, obviously it never forms any memories of making an unreinforced response. It never makes an unreinforced response to begin with. So it's never going to be able to associate those memories with eventual reinforcement the way a partially reinforced animal will. Okay. So according to the sequential hypothesis, partial reinforcement results in the animal's memory of non-reinforcement becoming a cue, becoming a signal to persist. Keep making the response whenever you remember not getting reinforced. And how this happens depends largely on the sequence of reinforced and non-reinforced responses that the animal experiences. So that's why this is called the sequential hypothesis. Okay. So for example, if an animal experiences a sequence like the one I'm depicting here, where it gets reinforced for a response, then not reinforced for the next two responses, then reinforced for the next two, then not reinforced, and then reinforced again, the critical responses in this sequence are going to be the fourth one here and the last one, because in both of those cases, the animal would be getting reinforced for making the response when it just hasn't been on the response prior, right? So it remembers not getting reinforced on that previous response. It makes the response again and gets reinforced again. And so again, it learns to associate its memories of non-reward, non-reinforcement, with eventually getting the reinforcer if it keeps at it. Okay. So the sequence of reinforced and non-reinforced responses is what produces this association between its memories of non-reward and eventual reinforcement. But obviously a continuously reinforced animal would never experience that, right? It would never get reinforced while it remembers not getting reinforced, because every response gets reinforced, right? And so it can't associate its memories with eventual reinforcement like a partially reinforced animal would. So like I said, the frustration hypothesis, the sequential hypothesis, they're similar explanations because they're both saying that during partial reinforcement, the animal associates something with the reinforcer that it eventually gets. The difference is just that the frustration hypothesis says it's the animal's feelings of frustration that it associates with eventual reinforcement. And again, the sequential hypothesis says it's memories. It's more cognitive. It's a memory of non-reward that the animal associates with eventual reinforcement. Okay. So either way, there's a similar kind of logic underlying both hypotheses, and they're not mutually exclusive either. It's not necessarily that one of these views is wrong and the other one's right. They're probably both barking up the right tree to some extent. In other words, it could be that during partial reinforcement, the animal learns to associate both its emotional state and its memories with the reinforcer that it eventually gets. Okay. Okay, so I hope all that makes sense. But one last idea that I need to tell you about today, a very different take on the partial reinforcement effect. According to what's known as the response unit hypothesis, partial reinforcement extinction effect isn't even a thing, right? Partial reinforcement doesn't actually produce more persistent responding. It doesn't actually increase resistance to extinction, according to this view. It only looks like it does because of how we're thinking about and defining the response that the animal is performing. And so the response unit hypothesis says we need to redefine that. it says we need to define it in terms of whatever the animal has to do to get each reinforcer, which on a partial reinforcement schedule consists of making more than just one individual response. Okay. So this view says it's not the individual responses we need to look at, it's the response units that we need to look at. So for example, suppose we have a rat in a Skinner box, and suppose we've got that rat on an FR2 schedule of reinforcement, meaning it's got to press the bar twice to get food. Okay. And then suppose we put it on an extinction schedule, right? And suppose that the rat makes 100 responses during extinction, presses the bar 100 times while it's experiencing extinction. Well, according to the response unit hypothesis, the important thing about the rat's behavior isn't that it's made 100 responses, it's that it's made 50 response units. Okay, so since it's on an FR2 schedule, fixed ratio 2 schedule, it's got to press the bar twice for each reinforcer, right? So pressing the bar twice is the response unit for that animal, right? And again, that's what we need to look at, not the number of times the animal presses the bar, not the number of individual responses that it makes. How many response units does it make? And guys, when you reconceptualize responding like that, the partial reinforcement extinction effect disappears. Okay, so that's what these guys, Maurer and Jones, originally reported in an experiment where they trained different rats to press bars on different schedules. So some rats were on an FR1 schedule, so they were continuously reinforced, and others were on either an FR2, FR3, or FR4 schedule. Okay. And then later they switched all the rats over to extinction, and they measured the number of times that the rats pressed the bar during extinction. They got the results that you're seeing in this graph. Now, in this graph, where we're looking at the number of individual bar presses that each rat made, it looks like there was greater resistance to extinction in the partially reinforced rats, right? With the FR4 rats making more responses during extinction than the FR3 rats, the FR3 rats making more responses during extinction than the FR2 rats, and so on, right? That's what it looks like. But again, in this graph, we're looking at individual bar presses, right? So here, a response is being defined as just one press of the bar. In this graph, we're looking at the number of response units that each animal made during extinction. So now we're considering a response to be the animal completing the entire behavior that's required of it to get a reinforcer. Now for the rats in this FR1 group, the continuous reinforcement group, for them, a response is still just pressing the bar one time, right? Because that's all they had to do to get each food pellet, right? So same number for them as in this graph over here. But the rats in the FR2 group had to make 2 bar presses for each reinforcer. So for them, a response unit is 2 bar presses, right? For the FR3 group, each response unit consists of 3 bar presses, right? So we divide whatever this number is by 3 to get the response units for that group. And for the FR4 group, there were 4 bar presses in each response unit. And as you can see here, when we redefine what constitutes a response like that, when we think about it in terms of response units, the partial reinforcement extinction effect disappears. Now, behavior actually looks like it's more resistant to extinction after continuous reinforcement, because that's where we saw the animals completing the most response units during extinction. And we get less and less resistance to extinction as we look at behaviors that were reinforced on thinner and thinner schedules. Okay. So to put it like your book puts it, partial reinforcement extinction effect is really just an illusion, according to the response unit hypothesis. Just a byproduct of the fact that in partial reinforcement, a response unit includes more individual responses than it does in continuous reinforcement. But change what you're analyzing from individual responses to response units, and again, voila, there's no more partial reinforcement extinction effect. Okay, so those are some of the explanations that have been proposed for the partial reinforcement extinction effect. Those are some of the leading ideas on why behaviors seem to be more resistant to extinction after they've been partially reinforced than they are after they've been continuously reinforced. As always, please let me know if you have any questions about any of those ideas, and I'll catch you next time. Take care.